Imagine, if you will, a sand grain representing our planet Earth in the vast desert that stands for the universe. This cosmic desert, my friends, is of a magnitude so immense that it's difficult to fully grasp. Now, let's ponder on the notion that there are approximately 2 trillion galaxies in this desert of ours. Each galaxy, a swirling mass of stars, dust, and dark matter, may comprise around 100 billion stars. As we go deeper into this cosmic voyage, keep in mind that the number of these sparkling celestial bodies possibly surpasses the total count of sand grains on all the beaches across our blue planet. It's a thought that's as fascinating as it is humbling. We find ourselves, on our tiny grain of sand, Earth, not merely in a desert, but in a desert that stretches beyond our wildest comprehension. Our journey, however, has only just begun. So, buckle up as we delve deeper into the cosmic abyss. Now imagine this vast universe has a beginning, a moment of creation. It's a bit mind-boggling, isn't it? Yet scientists have estimated the age of the universe to be around 13.8 billion years. How did they reach this staggering figure, you might wonder? It all boils down to cosmic microwave background radiation. This is the afterglow or heat left over from the Big Bang, which is detectable throughout the universe. By studying the patterns in this radiation, scientists are able to trace back to a time close to the universe's birth. Incidentally, this also gives us a hint about the Big Bang theory, the leading explanation about how the universe began. So, in the grand scheme of things, if the universe's existence were to be compared to a 24-hour day, humans have been around for just about a second, a mere blink in the grand cosmic clock. In this seemingly infinite cosmos, we only know a fraction of what it contains. The universe, it seems, is full of secrets, and 2 of the most intriguing are dark matter and dark energy. These elusive entities are believed to make up about 95% of everything there is. Yes, you heard it right, 95%. Dark matter was first postulated in the early 20th century, when astronomers noticed that galaxies were spinning far too quickly for the amount of visible matter they contained. It was as if an unseen hand was holding them together. Then came the discovery of dark energy. In the late 90s, scientists studying distant supernovae found that not only is the universe expanding, but it's doing so at an accelerating rate. This led to the startling realization that there must be some mysterious force, now known as dark energy, driving this acceleration. But what are dark matter and dark energy? That's where things get tricky. Despite making up the majority of the universe, we have little idea what they are. They do not interact with light or any other form of electromagnetic radiation, making them virtually impossible to detect. So it turns out that we are not just on a grain of sand in a desert, but a grain of sand in a largely unknown desert. The grand cosmic mystery continues, reminding us how little we truly understand about the universe we call home. As we journey through this cosmic desert, one can't help but wonder, what does the future hold for our universe? The answer, my dear friends, is as enigmatic as the cosmos itself. There are several theories that predict the fate of our universe, each as fascinating as the other. Let's take a brief look at some of these. Firstly, we have the theory of the Big Freeze. This suggests that the universe will continue expanding indefinitely. Over trillions of years, stars will burn out, galaxies will drift apart, and all matter will eventually decay into radiation. The universe would become a vast, dark, and cold place. Next, there's the Big Crunch theory. Here, it's proposed that the universe could stop expanding and start contracting. Everything, from galaxies to atoms, would be drawn back to a single point, creating conditions akin to the Big Bang. It's like the universe hitting a cosmic rewind button. Lastly, we have the Big Rip. This chilling theory suggests that the universe's expansion might not only continue, but accelerate. Eventually, this would rip apart galaxies, stars, and even atoms themselves, leaving behind a sea of isolated particles. As we gaze upon the stars, we are not just looking into the vastness of space, but also the vastness of time, where the future of the universe remains just as mysterious as its contents.